Welcome everybody on our Developing Wednesday. Vítejte na Rozvojové středě, která je první tento semestr. It's a great pleasure to introduce Arash Azadeh, the doctor from Univerzitě of São Paulo. He started his studies of bamboo in Mashhad at the university there in Iran, studying the Persian species of bamboo. Then he, simply to say, traveled the world with his engineering knowledge. He started his PhD at the University of Rio with the Professor Gavami, and now he's working at the University of São Paulo. Was it correct?
Yes, totally correct.
I will probably not speak more and ask you to share your presentation and teach us something what is not generally known in Central Europe. We don't have much bamboo. So welcome at the Czech Republic, as we are now online, and Arash Azadeh.
Thank you very much, and hi everybody, my friends that I cannot see them, but good evening for you maybe, because here is exactly the noon. And I start to present my presentation about bamboo, different aspects of bamboo engineering, cultivation, and many things, architecture, different aspects, and I hope you can use. The bamboo can be considered as green gold. Why green gold? Because in the poor countries, many persons which have not any access to the wood, they use bamboo for housing, for many different usage and different applications in construction also. Today we talk about what is bamboo, the bamboo structure, geometric properties, microscopic structure, bamboo as a functionally graded material, chemical components, and bamboo and engineering, bamboo comparing to other materials, engineered, what is engineered bamboo, physical properties, mechanical, and bamboo connections. And how about the bamboo protection? We have two different chemical and heat treatments. Chemical treatment and heat treatment, and bamboo in architectural design and other aspects of bamboo. What is bamboo? Bamboo is not wood. We should consider that it's a very giant, very big, and maybe you confuse between the bamboo and wood, but bamboo is not wood. It's a grass. It's a giant woody grass, and you can compare the size of bamboo with a human. For example, here you can see a piece of bamboo, and about the diameter is about 25 centimeters maybe, and different genus and species of bamboo we have. And you can see also Professor Gavami here, my professor, great professor, big research in bamboo in the world. And about the bamboo taxonomy, we can say we start with the bamboo, and after we should say about the genus of the bamboo. After the genus, we should say about the species of bamboo and the variety. For example, the family of the bamboo is the Poaceae graminae. Genus can be Dendrocalamus, can be Philostachys, can be Bambuosa, can be many different genus that we have. And about the species, we have the, for example, genus Dendrocalamus, species can be Giganteus, can be Asper, can be Stritus, Latifloris, and about the Philostachys, Edulis, Aurea, Nigra, and many different others. For example, for the genus Bambuosa, we have Vulgaris, Multiplex, Toldoides, and many different species, and we have the variety Vitata. For example, we have here the Bambuosa vulgaris, and exactly the same as Bambuosa vulgaris, we have the Bambuosa vulgaris Vitata, because it has a in the background, in the yellow background, you can see the green lines like a barcode. It's a very beautiful bamboo. And about the bamboo, important specifications. One of the most important is the high growth rate, and in some species up to 1 meter per day. But normally it's not for all of different type of bamboo. Only some species have this rate of growth rate, and most of them about 20 centimeters, 30 centimeters per day. The tensile strength of bamboo is comparable to steel, but the density is 1/10. It's a very important thing because it's a very light material, but the resistance is very high. The production cost is much lower than that of the conventional materials, for example, concrete and steel. Propagation through the rhizome as a root in the underground, that's a very propagates easily. You don't need, for example, cultivation, something like that. It's automatically grow and grow and grow, and without any problem. And it's prevention of soil erosion due to the formation of roots and rhizomes network that we have underground. It's very good. The another good aspects for the bamboo is the workability, and you can use it and you can change it to many different shapes very easily with the minimum tools and equipment. And it's very good for the it's a good material because it's a pest resistance before cutting, but you should consider after cutting you need to preserve bamboo and you should treat bamboo against the insects and fungus. The good conditions for growing bamboo normally are tropical zones and subtropical zones between 38 degrees north and south. Also, you should consider no severe cold and icy weather because it's, you cannot grow, for example, in Finland or, for example, in Norway, you cannot. But maybe you can grow in south of Europe without any problem. And also acceptable relative humidity. Acceptable relative humidity is for this plant is about more than 30 or 40%. It's good for bamboo. Here you can compare the climatic condition for various bamboo species. For example, Dendrocalamus giganteus. You can see the height is about between 25 up to 35 meters, diameter between 15 to 30, and you can see the hardiness. It's a -1 degree. And for example, for Dendrocalamus aspers, -4. It's better, can tolerate the cold weather. And the bambus of Volga is the -3. And you can compare the size here, diameter, height, and the minimum temperature can tolerate this different type of bamboo. We have also up to -20, or for example, for the Philostachys arcana. And the bamboo distribution in the world, we can consider, for example, the Asia, the Africa, and the America. And the continent of America is 28%, relatively 1/3, and the Asian Oceania is about 2/3, 65%. And Africa is only 7%. It's a very low the bamboo. And distribution and the diversity of bamboo in the Asia, you can see about the diversity, you can see in the China, the highest diversity, in India, and you can see the Vietnam, you can see here the Japan, Korea has, and Japan is, the situation is better. And Indonesia, Malaysia, something like that, that have only, in this region, they have bamboo. And in the Africa and America, you can see in the South America, it's more concentrated in South America. And in this region that we are now here, In Brazil, you can see the high diversity in this region that you can see in the Brazil. And now we talk about the bamboo structure and geometric features of bamboo. We cut the bamboo here inside the university. We have a section that we have bamboo Dendrocalamus giganteus. After cutting, we measured all of the dimensions, the wall thickness, diameters, and the distance between the knots. And the result, for example, here we presented the result. You can see, for example, the wall thickness here started from 30 millimeters and in average 2 centimeters, and in the elevation, for example, in 12, you can see about the 10 millimeters here, and bamboo distance between the internodes is about 50 centimeter, and here you can diameter about 12 centimeters. Meso and microstructure of bamboo, you can see the meso and microstructure. After cutting, we cut a bamboo section here, and in this piece you can see there a bamboo segment. Bamboo segment obviously has 3 parts. One part is a matrix or parenchyma. It's a porous part. Another is the sclerenchyma or the fibers, the part of which are responsible to the resistance of the bamboo. And you can see a porous part of the parenchyma. And we provide tomography from a piece of bamboo here in this part, and you can see the porous matrix and the sclerenchyma or fibers that are very dense and rigid and solid. And indeed, the matrix only works as the binder, the fibers used as a binder, exactly the same as the reinforced concrete that we can see here. For example, for a reinforced concrete, we can see the bars and we can see the matrix, which is concrete. Exactly the same happens for the cross section of the bamboo. We have the bars are the fibers, sclerenchyma, and the parenchyma or matrix as a binder. And you can see veins here also, the hollow tubes for the feeding the bamboo. Here we can compare bamboo and wood. You can see the annual ring in the wood, and also you should consider in the wood, in a tree, you have a transverse growth. Means every year, each year, the diameter of the tree became bigger and bigger and bigger. But for the bamboo growth, initially with the initial diameter, comparing the bamboo and wood, we can see the annual ring, and we cannot see the annual ring here in the bamboo, and no transverse growth. And you can see the Dendrocalamus giganteus and Philostachys edulis, and you can see in the radial direction, you can see the fibers. Here it's very dense, but in the bottom of the bamboo, we don't have any density in the bottom of part of the bamboo. And here we can see exactly in the top of the bamboo, in external wall of the bamboo, we can see the fibers, the high concentration of the fibers. In the lower part or internal part of the bamboo, you can see matrix or parenchyma. The density of parenchyma is more, means the concentration of the parenchyma is more. And in the Philostachys edulis also you can see exactly the fibers, the matrix, and here more density of the fibers, more concentration of the fibers at the external part. Now we can talk about the bamboo as a functionally graded material, and at first we should consider the principal directions, the longitudinal, the radial, and the tangential directions. It is a longitudinal, the tangential, exactly the same as the wood, and the radial direction, and you can see a piece of bamboo. It's a longitudinal direction, it's a radial direction, and it's a tangential. You can see from the internal wall to external wall, you can see the most concentration is in the external wall, and the minimum concentration of the fibers in the inner wall. For example, 31% at the inner and 61% at the outer layer here. And you can see it's a schematic graph for presenting this. Yes, it's a bamboo as a functionally graded material. Functionally graded material, in a functionally graded material, or FGM, the property changes gradually with position. And gradual changes, or you can define as a gradual change from one component to another alongside a direction, special direction that you can see in the radial direction. The component A gradually becomes to component B. And you can see exactly it happens here. You have more matrix here and less fiber, and here you can see more fibers and less matrix or less parenchyma. Chemical components of bamboo are mainly cellulose, hemicellulose, lignin, and extractives. The extractives are the aromas, resin, starch, oil, many different substances that you can extract from the bamboo. You can maybe use some solvents like water, alcohol, or maybe you use, for example, acetone or something or other materials to extract these aromas. But extracting the lignin and hemicellulose or cellulose needs another chemical, complicated chemical components. And you should know about the cellulose. It has a remarkable mechanical properties. The module of elasticity is about 120 or 140 gigapascal. It's excellent. It's the module of elasticity. And ultimate tensile strength is about 1,000 megapascal. It's 2 times or 3 times more than steel. But hemicellulose is not cellulose resistant, as you can compare, and the lignin. The hemicellulose and lignin only can be used as a binder in the structure of the bamboo. And we can compare the bamboo with different type of the hardwood and softwood. We have softwood, something like pine. We have hardwood. For example, we consider maple. We have many balsam, maple, walnut, and other eucalyptus. And only difference between you can see when you compare the bamboo with hardwood and softwood, you can realize that the bamboo is very close to the hardwood. And you can compare because of the lignin component that you can see. It's between 13 and 29%, and the lignin is the 15 up to 25%. But here it has a much lignin than to hardwood and bamboo. In the engineering, when you compare the bamboo with the other products, other materials, for example, 4 important materials that used for construction are steel, concrete, wood, and bamboo. And you can see, obviously, for produce 1 cubic meter of the steel, you should use the energy about 1,500 megajoule for producing the steel, but exactly for bamboo you can see 30, and you realize that 50 times difference is between producing the steel and bamboo. For the wood are closer, but yet bamboo is better than wood. If you want to compare the strength and resistance, the young modulus of some plant materials with the bamboo, you can, at first, you can see the cellulose here. The cellulose is the best situation related to the young modulus here, and related to the strength of the cellulose that you can see. We saw that was about 1000 megapascal, and here there's a good situation for the cellulose. We have lignin here. It's a poor situation because it's a less young modulus and less strength. And you have this 2 strips here, and that shows that the bamboo young modulus varies between 6 gigapascal to 25 gigapascal. It's the average. We have many different species of bamboo, and exactly it can be different. But in average, we can consider between 6 and 25 gigapascal. For the strength of the bamboo, we can consider 60 megapascal up to 250 megapascal. 250 megapascal for the tensile test, and 60 megapascal for the compression test that we will explain. I will explain for you why we have this difference. And the good situation of the bamboo you can see regarding to the other different type of woods, and if you compare in this region and this region. If you want to modeling bamboo with, for example, with software for Abacus, or with ANSYS, you should consider that the bamboo is not an isotropic material. It's a non-isotropic material. It means that you should consider the different Poisson ratio. You have different Poisson ratio, and you have different modulus of elasticity in each direction, longitudinal, tangential, and radial. You have different young modulus. And also, it's important you should notice that in the tensile and compression also, the module of elasticity are different. It's interesting. It's very difficult, the modeling of the bamboo. It's very difficult modeling the bamboo with software and considering all of these aspects. Now we talk about the engineered bamboo. We can use bamboo as a whole. For example, you can use a bamboo column as a column of the structure, as a beam, as a member of the structure, the entire bamboo, in fact. But you can also use some products from this from the bamboo. For example, you made a laminate with undensified or densified bamboo, something like this. And with a glue, you can make a glue band, like a glue lamp that we have for the wood. Here we have glue band, and you glue some bamboo, some laminate bamboos, and with a pressure or with higher pressure, with densification or without densification. It's the bamboo laminate that you use for flooring, and for example, you can make a bamboo screen bed. You can use make the bamboo strips and inside the resin, and with the compression and heat together, you can make the bamboo screen bed. And you can put some pieces of bamboo together, and with the pressure and heat, densify, and it's a densification process you can see. And when starting the densification, you have the 20% of densification, 30%, 50%, and finally destroy bamboo in 67%. It's you can densify. And as you remember, we have many porosity in the bamboo, and you can compress all of the porosity. You can see bamboo particle board, and you can see bamboo oriented strand board here. Also, 2 other products that made from the bamboo originally. The physical properties of bamboo mostly is related to water absorption of the bamboo. we have a phase of rapid water absorption for 1 day that absorbs about 53%, and finally a transition part, and a slow part. Absorption is very slow from the second, third day up to 4 weeks. And you can see it's a very slow absorption happens for the bamboo. You can see the weight increment here in percent, increment here in percent. And you should observe that the maximum swelling happen in radial direction for the bamboo when saturated with the water is 12%. And in the tangential direction is 7%. And it's very interesting because the maximum swelling in the longitudinal direction is 0.1%. It's a very, very low relative to the other two directions, tangential and radial direction. About the mechanical properties, we should talk about the tensile test, transversal tensile test, compression test, shear test, and bending test. In the tensile test that we tested in the laboratory, we understood that we realized that the ultimate tensile test in average for the bamboo is about 250 megapascals approximately, but the exact is for T1, T2, T3 in this dimension, this, and it's the CV, and it's the average for the E is the 22, about 22 gigapascal, and you can see the average, the CV of this test. It's a very close, a very low CV. It's very acceptable. That means that the test is very acceptable. In transversal tensile stress test, you can see the ultimate transversal tensile strength is about 5.5 megapascal, and as you can see, the fracture line pass through only the parenchyma, not the sclerenchyma or not the fibers, only the parenchyma. Then in this way you can measure the tensile resistance of the matrix. The compression also, you can use this apparatus for the compression test. And at first you should make some blades with 2 millimeters and 40 millimeters high and the wall thickness of bamboo. And after you can see the failure, what happened for this, and the local buckling of the fibers and rupture of the bamboo. In the compression test, dry and humid samples are totally different. For the humid samples at the equilibrium moisture content, with equilibrium moisture content about 10%, you can see about 60 megapascal. But if you dry the sample, you can see 152 megapascal, and it can be justified due to the buckling of the fiber inside the matrix and the relation of the volume fraction of the fiber and the shear modulo of the matrix, and you can the effect of the modulo of elasticity of the matrix and the fiber, volume fraction of the fiber. And with the humidity, we can have less EM and less EF and less also the shear modulo of the matrix. The shear test normally can be done with different type. For example, we can use a STM D143 for the blocks of the woods. It's a very usual. It's the apparatus that you can see. It's everywhere use this apparatus for the measuring the shear of the wood blocks. But as our geometry is very limited and we cannot make the block of the bamboo because of the limitation of the wall thickness of the bamboo, we should another method that proposed by ISO 22157, and you put this sample, something like that, and with 2x here and x here, and you can have the 4 shear surface in 4 different locations, and you can measure the shear resistance of the bamboo. We propose another way that we use 2 notches here and here, and we have a shear surface here. And with this shear test, we can realize that the 5.9 megapascal we have for these samples. And we have 4-point bending test, and we can understood that the modulus of elasticity is about 20 gigapascal, and you can see about the failure shapes of the samples with a low wall thickness and with high wall thickness. We can see failure shear happen for the samples and different type of the failures. And we can use also the dynamic test to measure the modulus of elasticity. It's a sonoelastic equipment made in Brazil, also with a professor by a professor here, and we use to measure the modulus of elasticity, but mechanical modulus of elasticity based on the impulse excitation technique. And the sample vibrates, the sound produced by the sample recorded by the microphone, and after analyzed, you can understand the mechanical property of the sample. If you want to compare the steel and concrete and bamboo rapidly in one graph, you can understand that for the steel in tensile and compression are equal. For the steel that we use for construction is 240 megapascal, and the ultimate is 360 megapascal. For the concrete tensile, we don't have, no, it's very, very low. For the concrete, for the, excuse me, it's a compression, it's not the tensile, it's a 20. And for the bamboo, for the tensile, we have 250, and for the bamboo is about 60. It's a relatively good situation regarding to the concrete and the steel. Bamboo protection. We have two main different bamboo protection. With one with the heat treatment with direct flame. For example, you use a flame, because by using the flame you can burn the starch and the sugar inside the bamboo, because the starch amount in the bamboo is high, relatively high, and you can burn this, and by caramelizing this sugar, you can protect it easily. And another way, using the chemical treatment and immersion in the chemical solutions like DOT, or the sodium octoborate tetrahydrate solution, which is the mixture of borax and boric acid and the special portions. And you can immerse for 1 week, and after drying, you can use it easily without any problem of any special insects or another attacks. Now we talk about the bamboo connections. The word of the bamboo connections are very, very diverse, because we have many different bamboo connections in the world. Every person use some and maybe invents a new way to connection of the bamboo. And because of the shape of the bamboo, the tubular shape of the bamboo, it's a little bit difficult to connect some parts. For example, consider this. In the traditional way, they use the fish mouth joints that made something, it's a grow here and use the bamboo and connect. And we have another connection here with the bars and metal anchor, and the technique. We use different position we can use, and in the vertical, horizontal, and we can fasten the screw and tighten the two parts of bamboo. We can join two bamboo with two belts and nut and bolts here, and you can fill here with, for example, in matrix, something like a light concrete, and use two straps or two belts and nut and bolt to fasten to different part of bamboo as a column or beam or everything. But you should consider that in this section, you should not have too much shear or bending. It's dangerous for the bamboo. We can use some ropes to fastening the bamboo, and you can see here, and you can see a space truss with some particles, some steel bars and something like that, and you can see the bamboo joints with steel clamps. It's capable of transmitting moment, and you can see here exactly that you have steel clamps here, and this part is used for the rigiding this part. We have another type of this fastener ring, and it's a bar and it's a pulley here, and it's a detail for the fastening different type of column or other thing together. And you can see here, and you can see here many details, and you can find in the internet many different type of connections, bamboo connections. You can see the role of bamboo in architectural design. For example, amphitheater that built by Bamboo Tech Group in 2012 in the Popíše, exactly my university that I studied my PhD there, and in the Rio de Janeiro. Here, and you can see the Cristo aqui, Maracana. It's a very nice city, very beautiful city, Rio de Janeiro. You can see the schematic design of the amphitheater here. This, and finally you can see in real situation. You can see the connections, you can see the size of this structure, and also in the right side you can see the bamboo, Bambusa vulgaris, that we have many in Rio de Janeiro. The inside part of this structure, and you can see the connections here. All of the connection is used the rope for fastening the bamboo together. And you should consider that they use also the steel cables here also for the tension parts, because it's a compression and tension. The role of the bamboo here most is in compression, and the column are in compression. And the tension, for the tension, use the cable here, the steel cable here, and the mixture of the steel cables and the bamboo. You can see with more details here. Another frame is very close. I don't want to repeat because another work with the Bamboo Tech Group. And they used two different type of bamboo, Philostachys aurea and Philostachys edulis, or moso bamboo. Moso bamboo has a diameter more than the Philostachys aurea. Aurea is used for the subsidiary elements, the secondary elements, and for the principal elements or the initial elements, they use the Philostachys edulis. It's a Bamboo Tech Group, and it's a Bamboo Tech site. You can go there and see another structure that made by them. It's a group, very nice group, and it's a Mario Seixas, my best friend. You can see art gallery made by architect Sven Moton from Belgium, but he worked in Brazil many times. He traveled and stayed here in Brazil and made many different bamboo structures that I will present two of them. One is the bamboo gallery that's very beautiful designing, and you can see the design. And you can see aura, the bamboo aura. Only he used here the bamboo aura with a special type of connections. And here you can see the type of connections, the part of wood designed for this and connect with a connector all together with these pieces, parts. And you can see the foundation, this plate, and it's a good idea because it's not directly in contact with soil, because it's better suggested that don't put bamboo directly in the soil because of the degradation of the bamboo. And it's a community center, Camburi, in Ubatuba, Brazil, 2018. And exactly architect Sven Moton again. It's located here between São Paulo and Rio de Janeiro. It's a plan, layout plan, and you can see it's a resort area for the local people that live there. And you can see the structure of bamboo here, and you can see the columns. Therefore, most of bamboo used as a columns here, for bamboo used as a column. Each group of column has 4 bamboo. And only presenting. Another, for example, sample from other country, Colombia, designed by Maestro Simon Vélez, a great architect that designed, for example, this Pereira Cathedral in Colombia. And you can see the very beautiful and nice structure here inside. Very nice and very beautiful. And many, for example, Santo Antonio Bridge, that, for example, is you can see a bridge with 2 parts, 2 support ramps here and another. And the distance between the support ramps is 45. And the bamboo elements here in the compression, not in tension, in the form of the compression. And only 2 heads, they use the concrete. And the average height is about 6 meters, something like that, 5.8. Another type of design, very interesting design by with the bamboo in the jungle. You can see different type of design here also. And one of the most interesting things that I found about the bamboo structure was the International Horticultural Exhibition in Beijing, China. That you can see exactly the same philosophy for the structure, and you can see the compression exactly. These arcs are in the compression, and they use this, and it's the pads that use here and here, and supported here, and after you can see the final result. That's very nice. You can see one of the most important, interesting thing is about the inventor of the airplane, the Wright brothers. Yes, can be, but the Brazilians believe that the inventor of the airplane is Santos Dumont, and used the bamboo frames to making the first airplane in 1906, I think, 1906. And unfortunately, what happened for him that the first flight has been done by the Santos Dumont in the world. But unfortunately, the documentation of this flight was very weak. And after that, they didn't accept them, but they didn't accept the Santos Dumont as the first person, and they accepted the Wright brothers as the first inventor of the airplane. But he's very, very important in Brazil, and we have the airport with the name of Santos Dumont, the Museo of Santos Dumont, everything. Santos Dumont is a very important person for the Brazilian people. Bamboo is edible and is very delicious. I personally prepare the bamboo shoots for myself, for family, for friends, and you can use it. It's very delicious, and you can make many different dishes with the bamboo shoots. And you can see, you can vaporize, and you can something like, for example, French fries or bamboo fries, for example, and many different things. Bamboo in cosmetic industry also used, and you can see the extractive of bamboo used for the many different cosmetic things, shampoo, sabon, something like that. Also bamboo used in handicrafts. You can see the Chinese and Japanese are very famous for this, and you can find different handicrafts from Japan and China and Korea and Thailand, and very different, the Far East Asia, in fact. These are very nice and beautiful, and also we have in Brazil many handicrafts, beautiful handicrafts. For example, Bluetooth speaker, Marley is very famous and very expensive. They use exactly bamboo laminated to making one of the most expensive speakers. And it has a good acoustical property. And you can see a nice bicycle that made with this person. I found in an exhibition in Brazil, and used the bamboo laminated and worked with this and made this very beautiful bicycle. Many thanks.